9.3, using point slope form. So that's the name of that form we just discovered. X minus h, or actually, let me start it off the same way they were writing it. Let me start off with y. So y minus k, where k is some y coordinate, equals my slope m times x minus h, some x coordinate. So we're going to model all of these equations off this, and this is known as point slope form. And that makes sense because we've got a point, x comma k, that's my point. I'm sorry, h comma k. That's the point I'm being given, and then my slope is just m. So that's why it's called point slope form. So we want to find the line passing through the point -2, 8 with slope 4/5. So I'm going to plug in 8 for k, and I'm going to plug in 4/5 for m, and I'm going to plug in -2 for h. Simplified, because I want to get rid of these inside parentheses here, I have y minus h equals 4/5 x plus 2. So you'll notice this is another case where when you see a minus, it's really a positive number, and when you see a plus, they're talking about a negative number. So that is a bit tricky. But if you look at the original equation, we're subtracting both these values, so it's going to be the opposite of what they appear to be. All right, another one. The line passing through point 0, 7 with slope -7/3. So my y coordinate is 7, so y minus 7. X coordinate, my slope is -7/3. And the point, my x coordinate, the point of my x coordinate is 0. So just x minus 0. And I can rewrite that simplified as y minus 7. You know what, I'm actually not going to rewrite that simplified because, who knows, maybe you'll see it this way. Y minus 7 equals -7/3 x. I don't know if you would call this point slope form. Usually you want to demonstrate the exact coordinate of the point, but perhaps they could give you this, or you could see this and you would know that if this was the case, when x is 0, y is going to be 7. And that sort of makes sense because if I add 7 to both sides, I get y equals -7/3 x plus 7. Now I'm in slope-intercept form, which is something you're probably much more familiar with, where this first number is m, right? Y equals mx plus b. That's the slope, and then this is the y-intercept. And the y-intercept is the value of the function when x is 0, so it makes sense that x is 0 up here and y is +7. All right, now they've given us an x-intercept. When y is 0, we know the value of the graph when it hits the x-axis. So that's going to tell me that I've got a y coordinate of 0, so I can just write y equals y minus 0. My slope is -1, and my x coordinate is 1/2. I could also just write that as y equals -1, x minus 1/2. All right, now they want me to write an equation for the line of this image. So the first thing I'm going to want to find is any coordinate I like. So I see this point right here is -2, 1. That's the point I want to use. You could use any point you see here. Really, -4, 0, 0, 2, 2, 3, 6, 5. Those would all be valid points. In fact, any point on this line you could use. Doesn't really matter. What is consistent is going to be the slope. So the slope, I'm just looking right here, rise over run. I'm rising 1, running 2, so that would be 1/2 as my slope. So putting it all together, y minus 1 equals 1/2 x plus 2. -2 is my x coordinate, so it'll be positive here. +1 is my y coordinate, be negative there. Number 2. Using the structure of the equation, what point do you know each line passes through? What's the line's slope? So I know that this graph, the x-coordinate is going to be -4, y-coordinate is +5, and the slope is going to be equal to 3/2. All right, this one is sort of like B above here, where we don't have anything being added or subtracted to x, so that means that the x-coordinate is going to be 0. So I can rewrite this as y + 2 = 5, x - 0. X - 0 is just x. So my point is going to be 0, 2, and my slope is equal to 5. For this one, we've given the x-coordinate, no y, so that means my y-coordinate is going to be 0. So the point I'm given is 5/8, 0, and my slope is equal to -2. All right, are you ready for more? Another way to describe a line or other graphs is to think about the coordinates as changing over time. This is especially helpful if we're thinking tracing an object's movement. This example describes x and y coordinates separately, each in terms of time, t. So number 1, on the first grid, create a graph of x = 2 + 5t with the domain, right? Since t is my dependent variable, this is sort of tricky, right? They made the x on the y-axis, and then t is the x-axis, so I don't know why they had to do it that way. This is my domain, right? These are all the possible values for my independent variable. So it starts at -2, including -2, and goes all the way to 7. And this is some review from your functions unit last year in algebra. So that means I'm just going to start my first value is going to be -2 for this function. So what I would probably do for number 1 is make a table. So for number 1, I've got t is my independent variable, so that's the first column. X is my dependent variable, my second column. Start at -2. All the way up to 7. So what I'm going to do is I'm going to multiply that t coordinate by 5 and then add 2. That's what the function tells us to do. So 2 times 5 is -10, plus 2 is -8. -1 times 5 is -5, plus 2 is -3. 5 times 0 is 0, plus 2 is 2. And you'll notice here we can see our rate of change of +5 occurring, so I'm just going to add 5 to save myself some time. All right, so now it's just a matter of plotting these coordinates on the graph. -2, -8. That'll be right about here. Since my scale is going up by 5, that means this point here is -10. -1, -3. 0, 2. 1, 7. 2, 12. 3, 17. All right, and I could keep plotting these, but since it's a linear function, they're all going to end up on the same line. So I'm just going to save myself some time and just make the graph. The one thing I do want to make sure I do is stop at t = 7, because that's where the domain ends. So that's the point 37, so I'm going to make sure I put a dot there to show my function is ending there. And if I put an arrow, that means it goes on forever, but this domain is only from -2 to 7. So that's as far as I'm going to go. All right. That's all I really want to do for this. I don't think this is super relevant to geometry, so I don't want to give you guys too much work. So that's all. All right. Have a great day.